Warner Street Lane Bridge. All right, here we go. Walnut Street Lane Bridge. We're going to show you that. Just waiting for somebody to pop in. Just trying to guess who this is. I don't know who this might be on this. Hermit. Somebody was on the other side there, and just want to give it a second to jump over. And I'll show you. I'll put them down below in the feed there. Hit the web page for that, and it will take you to Walnut Street Lane Bridge, the post-tension bridge, and you'll see that what we're going to look at. Let's look at this bridge live. Let me grab I got a few minutes of battery, like flipping over. I think this will still work for you. Yeah. So this is the post-tension bridge, right? Here we go. And I'll try to hurry it up. This is what it looks like, the first post-tension bridge. This is it, not much. It's Rick. Nice to catch you live. Hey, Rick. Rick, this is just talking about the post-tension bridge. This is Philadelphia. I put a link down below. You can click on, it will show you the Walnut Street Bridge. This is one of the first post-tension bridges in the country, United States. And as I fall down this trail, kill myself. I've got to hurry up. I only got like 16 minutes, 16% battery life. But we're going to take a quick look at this structure, the post-tensioning. As we get to it, I'm going to hurry up. So this is post-tensioning used, and the first in the United States, supposedly. It's been repaired a couple of times, so I'm going to try to get the view of it from a little bit closer. Battery level, great. So I've got to hurry up to keep this working. Give me a second. If you got any questions, you can sure ask about anything, and I sure will answer. So they used post-tensioning all over this thing, across the girder system, and the header system, if you will. And that's where we are down below. And that's what it looks like as a one unit, if you will. It's supposed to be the #1 in the country as far as it goes to post-tensioning. I don't want to go too close to. I think someone's got a auto fetish up here, and I'll show you what I mean in a second. It's Philadelphia. What do you expect, right? Hell of a hill. Hell of a hill. Give me a second. It's like trying to find the deer trail here. Good. Gosh. That was murder. That was murder. Still murder. All right. So now you see steel pans for the decking. Unlike in Florida, they use steel pans across there. across for the flooring, for the decking, and then these are just girder systems. But we deal with the FIU bridge. It's 175 feet. This span is, it's trying to scale it. Let me see. I'm scaling it. It's probably I had a laser in the car. It could have given me a real measurement. But we're talking. Let's see. 80 feet. 80 feet, and yet they used the scale, the slenderness factor, if you will, is huge. I should have got my darn laser. Yeah, to show you guys the scale. Now somebody lives up here, so we don't want to disturb him too much. It looks like he's into diet drinks. Okay, back to the signals back in. We're looking at members that are like 6 foot tall, and it's only spanning about 80 feet, whereas the FIU bridge used something about 2 foot tall, and it's saying 175 feet. The spacing of these guys are 4 foot apart. Let me get a scale on that. Did you notice it's not. It's this quote from Wikipedia. Let me see. Girders were pre-stressed by post-tensioning 4-wire cables embedded in the concrete. Can you explain basic steps in construction? So this is when they say fours, the length of this, and the length would probably stop right where that is, 2 of them together, probably right where the column is, where you've got that guy, and you're going from there to, well, it's slope. I keep falling down. So right now the load. Back again. My phone keeps telling me I'm losing signal. We've got some cracking going down here. It's an interesting location of the crack. You would think you'd want to observe that. With that said, we see what this one represents with the cracking. The other side, got to come back out. Show you the space. Show you shims. Show you the lose the signal. I was under the bridge. I kept losing the signal. So we look for indicators on top of the bridge, on the decking, cracks, etc. We observe none. It's great. Now the span is only what, 4 lanes, equivalent of 4 lanes, and yet they used reinforced members, the post-tension members, that were about 6 foot tall and spanned only about 80 feet, whereas 80 plus feet. Whereas the FIU bridge wanted to do this at 75 feet and wanted to use members that were super thin. Again, if you look at the link below, you'll see that what bridge we're on now, the post-tension bridge, and we saw it before the signal went out, what you have, images of it. Now, I'm going to jump over Walnut Lane Memorial Bridge. There we go. So now you see we're at that bridge with the post-tensioning. And you saw if the signal didn't cut out, you saw the spacing. Interesting, epoxies. I don't have enough battery life to get under there to tell you, to give the idea of what we got going on here, right down the center there. I'd like to see the repair. Connection intermittent, you have, Rick. So this is but I'm saying that the slenderness factor is major, and that's ultimately why that bridge failed under tension. It couldn't take, the slenderness factor was way off FIU's bridge. And using, knowns, this beautiful Walnut Street bridge, it's so far standing up pretty good with post-tensioning. I think you asked me about the 4 cables. I started to answer, Rick. The 4 cables are not just 4 single cables, they're a bundle, and they're fed through, video, but they're fed through, this just uses concrete here, at a profile, and I don't know the profile, maybe at the bottom of it, 1, 2, 3, 4, or if we're going up and down, hey, you'd have to see the drawings to determine what profile they chose. And now the loads on this are traffic loads, but they're also traffic loads equal a dead load. It's a live load. It's a hydraulic load, and they start slamming on brakes and doing all types of crazy things. Then you got the snow loads, and you got the heavy equipment and bridges, vehicles that come over this bridge. And I'm sort of wrapping it up, working my way down. Let's look at this. this connection here. And look at the rest. Now, I won't give it much thought. I won't give that much thought. But this is the... Somebody just popped in and it popped out. Okay. Yeah, if you look at the link below, you'll see that this is what the structure looks like. And that scale of the scale, number one, Rick. Hope that'll help you out or answer your question on that one. On it. I'm sorry I couldn't get more video underneath. Just that the live signal just kept dropping out because I was underneath the bridge. And now the phone should die out because I'm pretty much out of battery life. But just wanted to show you the Walnut Street Bridge. And there we go. So, I don't think I can get another shot of that. They're working on it. They're working on a couple of bridges around here, but that's one of them. It already went down already got mangled going down through the woods there to give you a shot of the look of the underside. So hanging up, Rick. Hope that was helpful. Anything else? Just look at the link below and I'll leave this video up so you can clearly comment on it. And if I can send you another photograph, I will. Or we can talk about it, I will.